going to obviously have to wait as usual. It's a bit frustrating this, but for those who are fortunate to not have adverts or are watching the VOD later on, tonight's going to be a bit different. So firstly, an apology that this is a Wednesday and not a Tuesday. It turns out I took X10 for immunisations yesterday, and well, they became quite a fussy individual and needed my attention for the rest of the evening. However, that's all sorted out now. We've moved on, and today we are now doing CodeZone on this Wednesday. And so who have we got? We've got Magetsub already, we've got Danny Chrome, we've got Alter Ego. Very good. And we've got Starfleet Clone. Hello. Oh, excellent. Good. Starfleet Clone is probably going to be a little bit underwhelmed with tonight's stream, I've got to admit. We're going to be talking about frame rates at a very simple level, because a question that keeps popping up, and it's an interesting question because I think it's flawed that people ask it, but they're asking it from a position of perhaps not understanding rather than any other reason, and that is it possible to fix the frame rate in something like the Pixel game engine or whatever? And my argument is, well, yes, it is, but why do you want to? And I thought we'd explore a few of these things as part of this video, because I'd like a resource that we can point people to moving forward. So, a little bit different tonight. We've got it. Shivix, hello. True Tonnes, good evening. Christian, hello. Null Alternative, hello. Lulu Gamer. Hi, oh, UDXS, hi. Yes, so that's a good example there, Starfreak. There's actually lots of good reasons for having fixed frame rates, but very rarely during gameplay, except for certain special circumstances. But if you do hear some crying in the background, there's not much I can do about it tonight. So I thought what we'd do is a very simple application just to explore this, because a lot of people are starting to program. It's that time of year as well when people are thinking, well, I've got to go to university or I'm going to school or something in September. It'd be nice to have some skills. And they start learning and they pick up something like the Pixel game engine or SDL or something like that and start hacking away with it. And frame rates are one of the sort of the first problems you've got to encounter. And the whole concept of having a program work in time. And time is not a nice thing to work with on computers. Now, these sort of frameworks make things a little bit easier, but understanding the limitations of time and some of the side effects of them as well. I think we'll have a look through some of these things. So a bit of a basic one tonight, but I think it'll be quite a useful thing for a lot of people. Goats, hello. Can't stay very long. Oh, well, it's okay. It's a bit unpredicted sort of Wednesday night stream this week. Couldn't make it last night. Megarev, hello. Tino, hi. Hermes, hello. Good. Well, got lots of familiar names turning up. That's good stuff. And so I'm really starting with a very blank application here. There's nothing to it. In fact, if I compile this, let's make sure this is the program I'm compiling. It's a good start. And I'm compiling it in release mode. In fact, let's pull up a little bit of that so we can see what's going on. Compiling it in release mode, and if I click play, hopefully we should get Pixel Game Engine, and it's chugging along on my display here. Maybe you can't quite see it. It's about 4,000 frames per second, something like that. Standard fur for the Pixel Game Engine. If I wasn't doing the stream at the same time, I'd expect that actually to hover about 5,000 frames per second. But there we go. And all that's doing is not very much actually. It's rendering a black screen, but it's actually redrawing 256 by 240 pixels in an array per frame. Not very much. Now, 5,000, 4,000 frames per second is a lot. In fact, it's a silly amount of frames, isn't it, really? Because your monitor is not capable of displaying that number of frames per second. However, it's a useful but incredibly crude metric of performance of how things are going. If you're writing something and it's going at 5,000 frames per second, and you add a line of code and it's going at 20 frames per second, something's gone wrong. So, who else have we got here? We've got, the Chazegg, hello. Yes, well, we do stream every week, but not usually on a Wednesday. So apologies to the Tuesday crowd that got disrupted. I had to change things up a little bit. To make the frame rate a little bit more visible, I'm actually going to display it, but I'm going to display it by looking at the period of f elapsed time, or the inverse of the period. So we know that frequency, f, equals 1 divided by time. So if we were given a time here, f elapsed time, we can take the inverse of that and work out what the frequency should be. And so that's exactly what I'm going to display on the screen to begin with. So I'll take want to make sure I get this right. Draw string, and we'll draw it somewhere near the top. In fact, we'll just draw it in the top corner. I always don't like drawing precisely in the top corner. We'll draw there. And I'm going to draw standard toString f elapsed time. Now, I'll explain what f elapsed time is in a second. F elapsed time, and we'll display that. We'll display it in white. White is fine. We'll scale it though by 2. And that should just display a nice big number in the screen. Well, what we want is 1 over f elapsed time, don't we? Now, f elapsed time is interesting because it's actually it's also known as delta time. It's the time between 2 identical points in the engine's update. So typically, you can assume that that time point exists just before this function is called. Gruffler, hello. Ulterior Offense, hello. Dragoneye, yes, hello. And Saucy63, very good, good to see regular faces. So let's have a look at that. That might make things just a little bit more visible. Now, the other change to this is the frame rate that gets displayed in the title bar is only updated once a second. Hang on, we're not seeing anything. Why are we not seeing anything? Why do we not see a thing? What's going on? Drawstring. F elapsed time. Is it not defaulting to white? Why are we not seeing anything? Oh, yes, sorry, my mistake. That needs to be a white there, and then the scale is the last argument. Perfect, yeah. Don't know what colour 2 is, but it interpreted as something. I guess it's something with a little tiny bit of red, I think. But we wouldn't have been able to see it. So let's try that. Ah, well, yes, we're getting something, but what I'm not doing is clearing the screen between frames. So let's try that as well. So clear, OLC, black. Well, actually, we'll let the chat decide today. What colour should we have for the background? Because we usually let the chats decide on the background colour for streams like this. Alex, hello. Ever considered doing an OLC car? Not magenta. Purple. Very dark blue. Please not magenta, because we went for magenta last time, didn't we? Is super dark blue? Now, that's an interesting question, because I think the Pixel Game Engine, if I recall correctly, stores in its least significant bit red. Black on teal. We could do teal. What's that? Teal is kind of dark cyan, isn't it? So I think we've got that as a constant that I know off by heart. Dark cyan. There we go. So now we're clearing the screen and we're going to be displaying the inverse of f elapsed time. And this is one of the reasons why I sort of cap it to only displaying once every second, is you can actually see the numbers. But we're looking, if we look at this in a snapshot, it's about 4,000 frames per second. We could filter it to try and make it a little bit more visible. Maybe we should filter it. Should we filter it? How do we filter it? If we take if we accumulate that and leak towards it as a sort of a sliding average, potentially, we could do that. Let's have a look. Float f average frame time equals 0.0. And if I do f average frame time plus equals f elapsed time, take f average frame time times 0.01, I'm going to go for. Have I got that the right way round? I've probably got that the wrong way round. And instead of that, we'll look at our average frame time instead. Average frame time. Is that going to work? Is that going to smooth things? Is it going to be too slow? Don't think that's working. That might be too intense. F elapsed time. Take the so when that comes in 0.2, that's going to be 2 plus equals that times a little bit. Might actually be too quick, given we've got thousands of frames per second. Morris is first. You're not quite first. Okay, that's sort of starting to filter it a bit. We probably do, because of the very high frame rates, we probably need to make the filter adaptive to the frame rate, and we'll talk about that later on. But roughly we're sort of looking at the same number, so about 4,000 frames per second. Good. Right, so we've actually filtered that. You know, I'm going to comment this because I think I will release this code at the end of the video tonight. So we'll just filter low. This is a low-pass filter, by the way. And it's needed for nothing other than looking at the time. Low-pass filter, F elapsed time for visualization. And the idea is if I sort of make this filter slightly slower or less leaky each time, we should see the number become more and more stable. But of course, it takes longer for it to actually get to an accurate value. So here you can see it's sort of settling down on the average value of frames. But because I want it to happen quite quickly, I'm going to stick that back. Plenty of ways to filter the number of frames. We could, of course, just display the actual frames per second as normal. Anyway, interesting diversion there. Let's have a quick look. Magetsup, have you updated compiler? Oh, you got standard format at long last. Very good. Yeah, I need to have a play with the standard format yet. It's interesting how the most cutting-edge parts of the C++ language are just re-implementations of printf. Yes, Magetsup was first tonight as well. Right, so what are we doing? We're looking at the timing. So the problem people come with is actually movement in games. Now, as I've already stressed, I've noticed there's a lot more people here than there was from at the start. The question that comes up a lot is, how do I actually use frame rates in my game engine, whether it's Pixel Game Engine or whatever? And it's important to understand that there are limitations to working with time and there are limitations to working with frame rates. One of the biggest problems people have when they've got really high frame rate applications, and I'm just going to see if I can make this work. So if I pull up Task Manager, there we go. If I pull up Task Manager and I run my application, let's have a look. There's plenty of reasons you'll want to limit the frame rate. So my application's running now. Task Manager, let's try and find it. Where is it? Algo frame rate is using 20% of a CPU. Well, it's actually using 20% of basically my entire CPU, which was the option to see these things. I'm sure there was a grid to change graph to logical processors. So basically I'm using, almost a quarter of my entire CPU speed, just simply displaying this number and a teal background. It's not very exciting, not very useful. There's also other things going on. Of course, I'm streaming and doing other bits and pieces too. So you might want to limit the frame rate in order to save your CPU some effort. So the first thing you would want to do is vsync it to your monitor. You want to only update the game at the same rate that your monitor can display frames. Now, in the UK, my monitor is about 50 Hertz. That's a bit strange, and that's because my monitor is a television and I live in the UK. It's not 60 Hertz. We can specify that as part of the construct function in the Pixel Game Engine. Now, other platforms and frameworks will have a different approach. But the construct function is full of little goodies that people never seem to play with. We've got the usual 4 values for constructing a Pixel Game Engine, but we've also got these additional flags at the end. So we've got full screen. We don't want it to be a full screen application this time around. So we'll set that to false. And we've got here vsync. Now, if we specify that to true, something strange happens. Cohesion, we talked about that in the tiling artifacts video. It was a couple of streams ago, wasn't it? So I've set vsync to true now. And what we should see is the frame rate goes to 60 and it slowly leaks to us. There's a problem with filtering these things. We need a much better adaptive filter than this. But this will sort of zone in, settle down on 60 frames per second. It's an average over, I think it's an average over about 10 seconds by the looks of it now. Now it's coming in slowly. We'll all watch this number count down. All 100 of us watching this number count down. You still have it at 50 Hertz? Well, apparently not. No, I don't have it at 50 Hertz. I have it at 60 Hertz now. I think that's because I no longer... I've not done any videos for about 2 months, and I don't have the camera filming the screen. So when I have the camera filming the screen at 60 Hertz, I get sort of wavy lines and patterns on it. So I knock it down to 50, and it seems to be in sync then. Because the video camera records at 24 frames per second, so there's some sort of interference going on. Anyway, okay, 60 frames per second. Now my CPU, if I pull this in, it's considerably less, potentially less, maybe not that much less. But if we look specifically at the CPU usage of the process this time, it's less than 1%. So something else is chewing through my CPU, and I'm guessing that's the streaming software. So by looking at by capturing sort of only the screen when necessary, when rendering only the screen when necessary, we've actually saved a lot of CPU overhead. Now, if you're running on a laptop or a Chromebook or a Raspberry Pi or something like that, they need every little bit of processing power they can get to prolong the battery. So, every bit of breathing space they can get to prolong the battery. Quite the opposite. So, interesting thing this. That's the first thing you can do, is to limit the frame rate. But it does ask the question, why do you want to limit the frame rate in the first place? And I think there's probably not very many valid reasons you want to actually fix the frame rate. So I thought what we'll do is we'll develop this application just a little bit more to explore how you could potentially fix the frame rate in a pixel game engine environment. But in order to do that, we need to have something to play with that we can actually see. So let's just quickly hack in some code. So I'm going to create a small position variable. We'll call it vpos. And I'm going to specify also a velocity variable, vf2d, and we'll call that vvel. And we'll initialize the position to be the center of the screen. I'll do that in onUserCreate. I'm just sort of putting my variables wherever at the moment. Vpos equals screen width divided by 2. And a screen height divided by 2. And because it's modern C now, it's going to all complain at me about the nature of the casting and things, but hopefully that warning's suppressed. We'll find out later. I'm going to initialize my velocity to 0. It already is initialized to 0. And at that location, I'm going to fill a circle. So we'll just take the fill circle routine, and we'll pass in the position, vpos. We'll specify radius of 10 pixels is enough. And we'll go for, what colour shall we go for the circle? Let's get the chat involved. I'm catching up with the chat. There's been quite a bit actually talking about frame rates. You still have it at 50 Hz? Yes, yes. You're having a nice big gaming monitor. Well, I have a 35-inch TV. That's what I use as my primary monitor. Is there really any massive advantage to having a monitor over 60 Hz? Well, the gamers will say yes. Well, there you go. Yeah, gamers will go, yeah, you need it, man. It's definitely important. But I think the neuroscientists amongst us will go, no, it doesn't make any difference. Orange. I think that's like the one colour we don't have. What's the RGB for orange? We should have orange, shouldn't we? Because given it's one of the staple OLC colours. Somebody bang in orange or 2551280. You don't have orange. Yes, I know. 2551280. Right, okay. 2551280. Red and bit of green. Is that really orange? I don't know. So anyway, that's what we're going for. And what else was I going to do? I'm going to set this average frame time just to stop that counter from taking forever to get to the target frame rate. To set that to a number. Let's just draw that. See, this should draw a orange circle in the middle of our teal background. There we go. I told you it would have some errors. I told you it would. This silly casting thing. It's silly now that it needs to be explicitly told to do this. It's annoying. I could actually construct the pause slightly differently, but using my initializer. Right, so we've got, well, it's I suppose that's orange. Orange on teal. That's a nice colour. What have we got here? Why have we got 0 up here? What have I messed up there? Oh, because it's not 60 frames per second, is it? It's 1 over 60 frames per second. There we go. That's a bit better. Why not add red plus yellow? Yeah, you could do that actually in Pixel Game Engine now, can't you? Yeah, you can. If I've not actually tried adding color constants before. Does that actually work? OLC red plus OLC yellow. I've no reason why it shouldn't work. Yeah, it's a slightly different shade of. Yeah, I guess that's because it's saturating red, isn't it? Because yellow will also contain a full lot of red. So you probably want to do something strange like this. We'll definitely do it. So this is what happens. So there we go. So yeah, we can we can do that with color constants. I'll put it back down as the actual pixel. Anyway, if you didn't know you could do that, you do now. So what we're going to do is position this pixel based on keyboard input. I'm going to move this circle around the screen. So if get key, we'll have OLC key up. Should we use arrow keys or WAS and D? I think for today we'll use WAS and D. Right. If that is held, then I want to move my velocity. I want to set the velocity of my ball. So I'm going to change the direction it's going to move in. Now I'm going to assume that each frame we're going to have to reset this down. So let's set this down now to 0, 0. And then, depending on which button configuration is pressed, we're going to amend the vector with a constant. So if we're pressing up, we're not moving horizontally, but we will be moving vertically up the screen. So that's a minus 1.0. Okay, and I'll just fill in the other keys pretty quickly as well. W, S, A, and D. Should have done all of these as one-liners, I suppose, but just to make it explicit, I'm putting in a plus there to show that it is deliberately opposite the minus up there. And for A is we're changing these around, so that becomes -1 there, and that one there. Now, I know to a lot of you this will be completely old hat and pointless, but you've got to remember some people haven't started really on their programming journeys yet, and it does no harm to sort of go over some of the basics. I reckon there's probably a few pros in the chat today that maybe don't think enough about the basics as often as they should do. Right, once I've set my velocity vector, I'm then going to change my position vector by my velocity vector. Now, it makes sense that if per frame, I just want to move my 1 pixel at a time, well, all I need to do is add to my position vector my velocity vector. Let's try that. So if I press A, we move to the right. If I press D, we move to the right. And if I press W, we're moving up, and S is down. And if I can actually move in diagonals, I can press left and right at the same time, and we don't move. I think I've just caught that in the chat there. What was the question? Because I saw Starfleet Clone sort of answering the question. I think it was an interesting question, but I don't know what the question was. Don't know. Yeah, you wanted to move diagonally. Yeah, that's exactly right. So that's why we're not using a switch. I mean, Starfleet Clone's spot on there. If we just only ever responded to the one button being pressed, we can't do diagonal movement, and it's just not as fluid either. So right now it's very, very responsive, and you think, well, this is fine. Look at that. We've got perfect control over the ball. How very, very nice. Well, it's all good until something unpredictable starts to happen in our code. So what do I mean by that? So I think what we'll need to do is sort of add some artificial strangeness to the program. Right now, we're basically every single frame we're updating our position with a fixed velocity, and we're not even looking at what the frame time is. we're making an assumption that our frame rate is going to be a fixed 60 frames per second. And if your application is typically running at 1,000 frames per second and you've locked in the VSync, it's a sensible assumption to make. Then potentially, it could be quite happily always chugging away at 60 frames per second. But I wouldn't ever really want to rely on that, simply because computers do other things. Your processor is sharing its resources with the rest of your operating system and other programs that are going on, and things like streaming and Chrome and video cameras, all that sort of exciting things, which are begging for a little bit of processing time. And thank you, TuxDude. Sorry, I've not got my sound effects on because I don't want to disturb X10. So if I do miss notifications, do kind of like shout out and ping. Thank you for the resubscription. Appreciated. Much appreciated. Is this about interpolation? Kind of. We'll get there soon. Okay. Thank you, Tuxdude. Right, so this is fine if we know that our frame rate is going to be fixed. So I'm going to add in some sort of deliberate interference. And I think the only way to sensibly do that is to whack in a great big delay into our program. Now, this does unfortunately mean digging out the fairly horrible standard Chrono rubbish, which I really don't like. I really don't like standard Chrono at all, because what I want to do is delay in my frame. So standard this thread sleep 4. Right. Now I'm going to put in something like... I'd like this to actually be a variable amount of time, I think. I'm going to need a way of defining this. Now I don't know Chrono off the top of my head, so we may have to dig out some of the documentation. But if I effectively want to... Can I actually specify a floating point number here? Has it got to be now a time point? Can somebody just bang out the syntax for actually, if I just want to specify a float here in terms of seconds, what is it? Yeah, I don't want to do the actual sort of this stupid unit stuff, the literal suffix thing. That's I want to avoid because I don't like it. Yeah, I don't want to do that. What I want to do is basically do 0.1, and that means a tenth of a second. Because what I want to do is put a variable in here. So let's pick a variable, frame delay. And I'm going to calculate that based on something. Yeah, is that it? It's okay, so it's in seconds like that. Yeah, I think that's right, Magetsa. It's standard Chrono seconds, and then you can just specify the number, can you? D frame delay, like that. Have I got to specify also that's going in as a double? Standard liberals. Do I need to sort of say double there? No. I hate Chrono. This is ridiculous. You want to do some timing Chrono? That's absolutely right. It's so complicated. It's unnecessary. Whilst the chat is getting... Oh, well, thanks, Magetsa, for not solving that problem. While somebody's getting busy with that, I'm just going to add in another variable up here, which is going to be an accumulation of the frame time. So decumulated time. And this is a running count of all the time since the start of the application. And I'm using it as a double and not elapsed time, which is a float in this instance. And there's reasons for that. If you do actually accumulate time for a long duration, elapsed time does actually go a bit wonky after a number of seconds. If you've ever used the PegX sound, and one of the reasons we don't recommend PegX sound really anymore is for exactly this reason. After about a minute and a half of use, the sound actually goes a bit strange. It changes in pitch. Very interesting for those that actually want to figure out why that is. Phil, hello. Davey, 40k, hello. Yeah, well, Megarev, yes, we know that that's how to do it, but it's actually passing in the number. Unless I've got something horribly wrong here. What's going on? What does it say? No instance of constructor period with long range. Yes, I need to tell it that it's actually getting a double instead. And this is why Chrono's just awful. It's just awful. Chrono seconds. I can't remember what the duration is. Duration cast or something like that we've got to throw in there as well. Seconds. That's going the other way, isn't it? Go on, chat. You're supposed to be helping me out with this sort of stuff. I don't know how Chrono works. I think there'll be 3 or 4 members of this chat right now furiously Googling to try and find the answer to this. And they'll be going, hang on, it shouldn't be this difficult. Thank you, Dunderstein. Well, I guess we're going to have to dig out the documentation then, aren't we? Hang on, let me pop up a window. Fine, right, okay, if that's what we're going to do live Googling of documentation time. That is standard chrono duration. Let's have a look at that. Standard chrono duration. What we've got represents a time interval. My general approach to using Chrono is to Google somebody's implementation of what else. Yeah. The Boxy Bear. Oh, the Boxy Bear. Hello. Thank you. I appreciate that. Well, tonight we're struggling with standard chrono already. We're trying to do an informative video about frame rate and how you can actually manipulate frame rate. But what I'm looking for is something that just makes it sensible to use. Treat as floating point. What's that? Indicates that duration is convertible to. Oh, that's there. This shouldn't be. It shouldn't be like this. Even the documentation is awful. I mean, just look at the state. This is actually making me angry. It really is actually making me angry that this is now how we do this sort of thing. Right, standard chrono duration cast, standard chrono minutes, second. Actually, I can't pass that in. Duration, yeah, I thought it was duration cast. I said duration cast. Nobody helped me out there. Duration cast. Awful. Standard chrono. Duration cast. Ugh. What do we need to actually cast it to? Hang on. This is where I do need the docs. Duration cast. Duration. Oh, dear. Come on, Chrono, help me out. Ambiguous local time. Where is my duration? Where's duration cast? Where's that buried within? Duration cast. There we go. Duration cast. Example of duration cast. Sleep 4. So we know that, but we want to put a variable in there instead. Duration cast, standard chrono milliseconds, and then we can pass in time points. Time PegX. A time PegX would be a good idea. Oh dear me. Right. Okay. So duration cast, and then we want to cast the specific time, and then we can create a time point based on. There we go. So that's what we're looking at there. Standard duration. Is actually the two. It's the two things together, I think. There we go. We got there in the end. Awful. If this is a family-friendly stream, so that's why I'm not swearing. But normally I'd be like a drunken sailor at that point. That is abysmal. Thank you, C++ Standards Committee. So, well, anyway, we got that far. So what I'm now going to do is, in my accumulated time, I'm going to increase that every single frame. So, d accumulated time plus equals f elapsed time, and we'll have to cast this. Now, I'm not doing the static cast thing. I've not got the time. So I'm just going to lazily cast it like this, basically to shut the compiler up. And I'm going to pass that in as an argument to my frame delay. But I want this to not be too slow. Right now this has got a period of 1 Hertz. Is that right? So I want to now increase that to something like 10 hertz at the moment. I just want to make sure this is going to work. That's in milliseconds. I actually want that to be seconds, don't I? So that's going between 0 and 1 and -1. I don't want -1, do I? Oh, why can't I put seconds here? Seconds. Right, fine. We will do... Surely seconds must be a thing. What? What? Okay, we'll have to play around with these numbers then a little bit more. So this is going to be in milliseconds. So whatever it's going to be, we want to multiply that by 1,000. But I do want to make sure that actually we're taking this value and then adding 1 to it and dividing the whole lot by 2. Ugh. Put some brackets in there. So that's giving me a delay between 0 and 1/10 of a second, I think. Not quite, because the amplitude is... So I'm going to set that to be 100 there, rather than 1,000. So that should give me between 0 and 1/10 of a second, I think. I think so. Yeah, we get to at this point. You always just fall right back to just using regular sleep commands. Right? Okay. Has any of this worked? Let's have a look. We'll get loads of compiler complaints now saying, "Oh, no. Looks okay. Looks happy." So let's run that. And what do we get now? So what we've actually got now is something with a varying frame rate. So if I hold down the movement, oh, there we go. We've got a problem. It's not very smooth. And that's because we've chosen to move the object precisely a fixed amount per frame. Now, you can imagine if you've got a frame where suddenly you've detonated a bomb or something in the game and you've got debris and everything flying all over the place, suddenly you've got thousands more objects to update. You've just immediately dumped a massive load in the nicest possible way on your processor. And it's got a lot to do all of a sudden. So that particular frame, and maybe the frames immediately after it, as all the collision and everything's being resolved and all of the new spatial data structures are being calculated, all of these things are being thrown into the mix. Suddenly you've got a frame rate dip, and you might go well below 60 frames per second. And we call this lag. And lag is the scourge of gamers. So we've deliberately sort of included lag into our application. Now we're looking at the average frame rate here rather than the instantaneous frame rate because we put that filter in. We can see that's sort of averaging out at about 27 frames per second in this case. But that's no good, and this is because we're now moving our object precisely by a fixed amount per frame. So how can we deal with discrepancies like this in time? Well, we do what I've always tried to encourage anybody watching the channel to do, and that is any variable that is temporal, we actually modulate with our elapsed time value. It's an important concept because you don't know what the frame rate is going to be, then you need some way of understanding potentially how to change the illusion of movement. We'll get to a second part of this hopefully soon, which is where we'll look at how do we actually fix the frame rate. But for now, let's just look at just modifying this to suit the movement. We know that we've got a velocity, and we know that speed equals distance over time. That is our main formula. Right, so if we've got our speed, I'll just do speed equals distance divided by time. We can rearrange that to tell us how much distance should we move is equal by the speed that we want to move multiplied by time, or a duration. Well, vpos is our distance that we want to manipulate. In fact, we're going to change by basically delta dpos, vpos in this instance. And that's calculated by some speed constant multiplied by a time coefficient. Well, we happen to have a speed constant here. And we also happen to have a timing coefficient here. So we can just modulate. I call it modulation. I know some people just like it multiply, but we can multiply here by f elapsed time. if I can spell it properly. There we go. Now, what this will do is try to overcome some of those unpleasant movements that we saw before. Well, maybe they were quite pleasant, but it'll be very slow. So it's consistently sort of going tick, 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 but it's very slow. And that's because now we're moving at 1 pixel per second, because that's the velocity that we've told it to move. Only move at 1 pixel per second. So I'm going to increase the scale of this. And we can do that simply by eval multiply itself by, I don't know, let's pick 20. So our maximum speed is now going to be 20 pixels per second. So instead of doing a fixed amount, 20 pixels per frame, we're now looking in real term speeds. We've sort of moved it into the world of physics now. And it won't perfectly smooth things out, and particularly in this strange situation where we're manipulating the frame rate. But it should give us a better, as I say, it won't be perfect. And that's because we've got quite a huge discrepancy going on between frames at the moment. But it's starting to smooth things out. But also, even though it looks awkward, it is actually mathematically accurate. So it might not look as good, but it is taking the correct amount of time to get from one part of the screen to the other. It might not be doing it smoothly, but the ball is moving with the frame rate that we wanted it to move at. So it's not perfect. And one of the reasons it's not perfect is we're always looking at the previous frame's time. And that's it's a hack, right? It's not a perfect solution at all. We looked at how long did it take on the previous frame, record that information into FElapse time, and passed that into our velocity multiplier for this current frame. Well, we know that we're changing our delay deliberately per frame, so not that good. What we can do now is actually take out this delay momentarily and have a look at how does this behave. So we're not delaying at all, and hopefully we should see that the ball starts to move quite smoothly. So this has now gone back to our 60 frames per second, and the ball does indeed move very slowly. In fact, it moves probably a bit too slow to be entertaining. So let's just increase that. We'll double its speed, 40. So there we go. 40 pixels per second's worth of movement at, well, as you can see, the frame rate isn't fixed. Well, it kind of is fixed. It's about 60 frames per second. But one of the things we should be able to do now is take off the VSync again. Run the application. And we're now running at get it up there to about 4,000 frames per second, and the ball moves with exactly the same speed. So we've decoupled the movement of objects in our game from the frame rate. And at these high frame rates, we can actually see the frame rates vary quite considerably depending on what's going on. It's a bit difficult at low frame rates, sort of the sub 60 frames per second, but at these very high ones, we're getting changes of several hundreds of frames per second per frame. Right, I'm going to just catch up with the chats whilst I have a slurp of water here. Just a second. Yeah, Dandestein's got me covered. Yeah, well, Dandestein's gone on my list now. You're making a game, right? Yes, I am, but tonight I'm looking specifically at frame rate implementation problems because they keep coming up on the Discord server as catching people out as to why they shouldn't use fixed frame rates and what do they do about it. And hopefully with this little application, sort of demonstrated that you can decouple your in-game movement from your frame rate quite easily with FElapse time. But now the next sort of phase is what do we do if we deliberately want to sort of cap the frame rate to something quite low? It's an odd request that people have, but nonetheless, it's an interesting puzzle for some people. There are situations where if you've got very simple game logic, then actually moving a fixed amount per game state update makes some sense, rather than getting bogged down in physics. One of the downsides to this approach is I need to represent the ball here as a floating point, because it can quite happily exist in between pixels on the screen. Well, if you've got a processing system where floating points aren't available, you've only got integers, and you're not interested in doing clever fixed point manipulations, well, then you probably are working in the domains of moving by a certain amount per frame, a lot like the old NES games did, and many of the old console games. That's why they suffered from lag when lots was going on the screen. What do you do when the frame rate is so high that the f-elapsed time variable can't hold the tiny delta value and effectively ends up holding the value 0? That's a good point, Alter, and it does happen. That can happen particularly on the startup of the application if you've not got it quite right. I would just simply not pass the frame. I wouldn't allow the frame to happen, and I can't remember, it might be worth a check. Does Pixel Game Engine actually deal with that circumstance? I don't think it does, because I think in the past I've done it manually. When I've been experimenting and took out any kind of rendering, you were getting very, very small delta values. Where's the core loop in Pixel Game Engine? The core is... somewhere. We're getting closer, getting closer. On-use updates. Oh, that's for the extensions. On-use update for the module itself. Where am I doing my timing? F-elapsed time. No, actually, no. It doesn't look like I'm filtering that condition. I think it's almost impossible now for that condition to happen in Pixel Game Engine anyway, because there's actually a fair bit going on between frames. But it can happen. I would just check for it and just simply do nothing. Do nothing for that frame. Because it actually makes the best sense. If your delta time is telling you, well, no time has elapsed, then nothing should change. Right? Time hasn't progressed. The state of your system can't have changed. So that's how I would treat it. Best thing to do is to decouple physics completely. Yes, that's true. Quite a few people do actually do physics totally separately, and I've actually done that in my programming balls video, where we look at handling time a bit more sensibly in physics. Doing rudimentary movement on the screen like this is very simple, but it's not very good for handling collision response. I know there's quite a few people on the server right now doing collisions, particularly Megarev, and Alter's always doing collisions. Rogue, for those old enough to run DOS games, yeah, well, that's it. They do. They run at insane speeds because exactly this reason. Possibly they were so old there weren't even floating point co-processors back in the day. Speedy, hello Speedy. Yeah, sorry Speedy, we changed days today. I do always keep things up to date on the content creators page on the Discord. Can you decouple user input? Well, that's hopefully where we're going to go with this, because that's really the biggest problem. So let's we've got 10 minutes left. Let's actually go ahead and implement now an artificial frame cap, or how I think I would implement an artificial frame cap. And basically, I always tell people accumulate f-elapsed time until you get to the situation where you want to do a ping. So let's put some variables in here. Right, I'm going to have some more. Accumulated time. So ignore the accumulated time above us, it's a double. This one is going to be in floating point. And I'm going to set my frame rate. So target frame rate to be, let's say, 30 frames per second. So again, we'll do frequency equals 1 over t, therefore t equals 1 over frequency. Target frame rate, 30 frames per second. And in my loop here, I'm going to accumulate f-elapsed time. So I'm going to accumulate that in my f-accumulated time variable. So far, so good. But what I want to check is, I only really want to do anything on the 30 frames per second tick. So I can do that by checking, well, has my accumulated time, has that surpassed my target frame rate? Or is it equal to? Yes. Greater than or equal to. And you might think, well, now you can do your stuff. But always first, instead of just immediately resetting f accumulated time to 0, Right? This is bad. Don't do this. Instead, from your F accumulated time, subtract the excess time. Do this instead, because more often than not, accumulated time is going to be larger than your target frame time. So if we've set it to 30 frames per second, we may actually be at about 30.2 frames per second. And it's important that we don't lose that 0.2. So we'll bundle that in to the next round of accumulated time. So this is a much better way to do things. This will ensure that your tick remains somewhat accurate. So it's tempting then to now just stick everything into this if statement. And so we'll do that. We're not doing any of this artificial delay anymore now. You stick everything into this delay. The downside now is our F elapsed time here is no longer the right number. So I'm going to take those out either. Because F elapsed time is time per system frame. We're not delaying anywhere, but we're now basically fixing back to frame rate. So I'm going to take my target frame rate, and instead of F elapsed time, that's what I'm using, because that's my equivalent. We're now doing an update on every 30th of a second, as it were. So let's just see if that still works. I've probably messed something up here, but we'll see. So now we've got the application. The game engine is running again, 4,000 frames per second, but the ball is only moving at 30 updates per second. In between those updates, in Pixel Game Engine, the screen will remain static, so we don't actually see those changes. So it kind of looks and feels about right. But there's a problem. And as I find the user that said it, flipping heck. 666. Whenever I see that name, I go, I don't want to say that in case I say something rude. Is this? Can you decouple user input? So now we've got a problem with user input, because if we're only doing everything on this 30th of a frame tick, the user has a very small window in which to press the keys accurately. For this one, it doesn't matter because the key is simply being held. So that's basically a check all the time. But let's say we wanted something that was responsible for a key being pressed. Can we emulate that? What should we do if the key is pressed? So if the key is pressed, F radius. Right. If get key OLC key space dot be pressed. If the key has been pressed, then I'm going to set my radius to 20. And I'm going to keep the radius at 20. I think we'll stick this up here until I press a different key. So we'll say if key is pressed, set the radius to 20. If it's not space, we get rid of, instead of space, let's just change these to something sensible. I'm going to change this to Z and X. And if we set it to... Sorry, I want to just set it to Z. I'm sort of thinking it too far ahead here. And we'll have that as released instead. And we'll change this value to the radius value. So what I'm going to do is when I press the Z key, I'm going to inflate the ball. And when I let go of the Z key, I'm going to deflate the ball. And we'll see what happens. So the ball is moving around, and I press the Z key, nothing happened. I release the Z key, nothing happened. So I'm going to keep pressing the Z key. Well, if I've coded it right, the chances of me actually pressing the Z key at the same time that my frame tick is working Well, it's almost nothing. It was 1 in, 30 of a second. It's not good. Apologies if you're wearing headphones there, I just caught my microphone. So yeah, standard in. User input has to happen as fast as possible. Exactly. So we actually need a way of somehow capturing the user input outside of this tick rate. Random question about classes. Is there a performance benefit from copying a class field to a local field? No. I would argue that potentially even in Java it didn't do anything, simply because as soon as your code is compiled, the entire notion of classes has disappeared. Danicron, accidentally snipping off little bits of extra accumulated time. You know, it's not an uncommon thing. People just sort of go, yeah, I've got to reset now. Oh, good. Well, I'm pleased that somebody like Danicron, who's got some experience at these sort of things, has actually learned something there today. Good. I think there's an assumption here that your main loop won't ever be significantly longer than the tick rate. Yes, that's true. If your game engine starts to just fundamentally collapse, there's nothing you can do about that. Toggle magenta background. 1 in 4,000. Is it 1 in... Yes, actually, sorry, you're right, Danderstein. The odds are almost nothing, aren't they? Because this 30th of a frame... presumably, yeah, the 30th of a frame... No, it's 1 in 30. It's 1 in 30. I'm sure we'll debate that later on the server. So what can we do about this? Well, simply put, we have to try and take sort of time-sensitive user input out of our main loop. So not when we're doing the tick. This sort of input has to occur every single frame. It's okay to sort out the input every single frame. We're only updating our game state on the tick rate that we've specified. So there we go. So I'm pressing Z and let go of Z, pressing Z, let go of Z. But our game is now running at a 30 frames per second tick rate. I believe it's in Minecraft. Is that what they call it? Tick rate or something like that? Because it's deliberately slow, sort of the game update rate. So it's important, particularly in Pixel Game Engine, to capture your input outside of your tick. I think that probably applies to pretty much any game engine where an event system works, just simply because the probability of your events coinciding on the correct frame along with your tick is so remote, you'll have all sorts of input problems. So these are basically temporally sensitive inputs. It's a press and release. They're effectively events. And that's different to the W, S, A, and D keys, because we only care if they're held or not. We're basically checking, is that key held down? It doesn't matter quite so much. And I think we've timed that quite well, because we've looked at all the different types of frame rate handling in Pixel Game Engine. At least we've looked at V-syncing, we've looked at filtering the frame times, we've looked at manipulating objects moving across the screen, we've looked at how to handle velocities, we've looked at now setting the frame rates to something sensible. I think that should be a nice resource for anybody that needs to learn about frame rate handling. Would it be better to capture input asynchronously or on a different thread? Firstly, I should point out, Dark Alpha, absolutely no need to prefix any kind of questions, particularly in anything that I do. So One Lone Coder is all about letting people ask questions that they might not be familiar about. At least you're asking the question. Would it be better to capture input asynchronously or on a different thread? That just, to me, sounds like we're adding complexity. So certainly adding a different thread to handle the input. I mean, all of these things are possible, totally possible. It depends on several factors. Predominantly, what is your input system? So, for example, on Pixel Game Engine, it's using a Windows event loop, which ultimately stores the events in an array within the Pixel Game Engine. That's different to how it works on Linux. So your Pixel Game Engine application doesn't really see the difference, but how you go about implementing the keyboard event handling is different depending on the platform. So would I go as far as using a different thread for input? No, probably not. Capture it in asynchronously. Well, what is asynchronously on a a PC and an application like this, arguably anything that is event-driven is asynchronous, and your operating system does behave in an asynchronous way for the events. The downside is at some point that you've got to turn that asynchronicity into something that is synchronous to make sense of it, because our game engine simply accumulates input, it updates the game, and it displays things, and it will just keep doing that in that sequence. So that's a synchronous action needs to be part of that sequence, which is synchronized at some point. Does anybody know how SDL2 does it? It seems to have an event loop. Well, there are a few event loop systems. Pixel Game Engine is actually fundamentally an event loop too. On Windows, it's slightly different for Linux. If we're going to have a look at the platform implementations, got to try and navigate this code. Where are we looking? This is... do you know what? I should just look for the classes. Platform Windows. There we go. Why has it took me here, of all places? What? That's not platform Windows. Platform Windows handle system event. This isn't. What is this navigation? This is rubbish Visual Studio. Okay, on the Windows platform where we've created the window and things, the final thing that happens is here. So there's a function in Pixel Game Engine called Start System Event Loop, which is, if you're familiar with WinAPI programming, this is the core loop that's handling the event system for Windows. So it's strange in Windows that the window itself is sort of doing one thing, the Pixel Game Engine is doing another. That's different now if we go and find the equivalent on Linux, which is that one. Because Linux doesn't do it in this. It doesn't have this start system event loop. Sorry, it has instead. Here we can see the event handler. This is a typical Windows event handler. That's what they look like for your standard WinAPI application. So this is where we handle things like mouse and keyboard input, that kind of thing, and we inject that information into the Pixel Game Engine as it's running. So the Pixel Game Engine's in its own thread doing its thing. Arguably, all of this input is handled in a different thread, but it's handled by Windows fundamentally. I want to try and find. It's probably this one then. So in Linux, yes, it's actually. You poll the event system rather than having it injected directly. So on Windows, the operating system sort of shoves it into the Pixel Game Engine. On Linux or X environments, we ask the environment, has anything happened since the last time we asked you? So there's two different approaches there for the different platforms. Sorry that took so long to answer, but pretty important. Daz Lixu, sorry, I'm catching up here. I'm quite far behind. Is there a YouTube legend streaming? Brilliant. Yes, put a link. Maybe that's the Windows event loop too. Yeah, it kind of is. Okay, we've covered that already. Oh, Dragoneye posting some links though. Yeah, try to look for X event. We found it in the end. There we go. That's good. Right, that is it from me tonight. So sorry that's a slightly strange stream. It came about because we must have been asked 50-something times on the Discord server, how do you handle timing and frame rates in the Pixel Game Engine, but I think it's applicable to all game engines really. So hopefully we've covered a few basics, and we've got something we can create a tag for on the Discord server, and we can link, and potentially could even be a video on the main channel. So until then, I can't hear X10, so either something terrible has happened or something amazing has happened. Well, I'll see you next time. Thank you very much. Yeah, sorry, the streams are only an hour. All the VODs are uploaded to the JaredX9 channel, and of course you can catch them on Twitch after this. So I'll see you next week, hopefully Tuesday, 8 o'clock, if not before. Take care. Bye.